Alright, section 11.3, perimeter and area of similar figures. Our goal again today is use ratios to find areas of similar figures. So back in chapter 6 we discussed that the ratio of the perimeters is equal to the ratio of the sides. So here we have two polygons, polygon A on the left, polygon B on the right. The ratio of sides is A to B. As we discussed in in chapter 6, the ratio of perimeters is also A to B. The ratio of areas is A squared to B squared. We're simply squaring each value. It says the ratio of corresponding sides is 3 to 5, so that is A to B. So what we will do is we will say that A to B is 3 to 5. It says find the ratio of areas. So we need to get to A squared to B squared. So this becomes 3 squared to 5 squared, which is 9 to 25. The next example here, we are given two similar rectangles. We are given a length of 18 and a length of 10. Find the ratios of the perimeters. Again, ratio of perimeters is equal to the ratio of sides. So we have 18 to 10, and all you need to do is to reduce this to be 9 to 5. Again, the ratio of areas is A squared to B squared. So we have 9 squared to 5 squared, and this is equal to 81 to 25. Remember, when working with A to B, you always want to simplify the ratio as much as possible. That way, when you are squaring it, there will be no simplification needed. Alright, find the ratio of the side lengths with the given ratio of similar figures. So it says the ratio of areas is 100 to 81. So you have A squared to B squared is 100 to 81, and you need to convert this to A to B. How do you get from A squared to A? That's right, you square root both sides. Square root of 100 is 10, square root of 81 is 9. 10 to 9 does not reduce, so this would be your final answer. Ratio of perimeters is 5 to 10. Ratio of perimeters is also A to B. So all you need to do is reduce this 1 to 2, and that would be your final answer if they give you ratio of perimeters. Problem like this, you're going to need to draw a diagram. So the small flat screen TV is 24 inches wide by 18 inches high. What we're going to do is draw ourselves a couple rectangles here. One to represent the small, and one to represent the larger TV. So we have here the small and the large. And it says it is 18 by 24. And it says the larger TV is similar and has an area of 675 square inches. Find the dimensions of the larger TV. So we don't have any dimensions on the smaller one. What we can do is find the area of the larger or the smaller. So we have the area of the smaller one is also 432. We now have the ratio of the areas. So we have that A squared to B squared is equal to 432 to 675. Now neither one of these are perfect squares, but if we divide each by 3, we get 144 to 225. And I recognize that these are squares. We will then convert these to be A to B. So we're going to square root both of them, and we get that the ratio of sides is 12 to 15. Back in chapter 6, when we did similar triangles, we did our ratio, so we knew that 12 over 15 was equal to, and then use a dimension. So for example, 18 inches over the height of the larger one. And now we are going to cross multiply and solve. And we are going to do the same thing for finding the length. Now, could you do 675 divided by 22.5? By all means, you could do that as well. Could you reduce the 12 to 15? By all means, you could reduce this to be 4 to 5 as well, if you want. So we find here that the length is 30 inches. So what are the dimensions? Length is 30. Height is 22.5. Our last one. The pentagon is a regular pentagon. Each side length is about 900 feet, and the area is about 1.4 million square feet. You build a scale model, and again, we're not asking why you would build a scale model, but you are, whose perimeter is 30 yards. Find the area of the base to the nearest yard. So we're trying to find the area of your model. So we got here the regular pentagon has sides that are about 900 feet. And again, they're all congruent. And the area is 1.4 million square feet, or 1,400,000. Alright, and then we also have your model here. And with your model, again, we know all the sides are the same. And we know that the perimeter equals 30 yards. So we're going to divide that by 5 and find that each side is 6 yards. Now we run into the issue of we have feet on one problem and yards on the other. Our answer says nearest yard. So right away I'm going to convert 900 feet to yards. So 900 feet times 1 yard equals 3 feet. Cross it out, we get 900 times 1 is 900 divided by 3. We get 300 yards. So, just like before, we're going to go ratio of sides. 300 to 6, which reduces to be A to B is 50 to 1. In order to find the area, we're going to need ratio of areas. So we are going to go A squared to B squared. And again, this will be the areas. So we're going to square both of these, and we get 2,500 to 1. We will now set up a proportion. So 2,500 over 1 is equal to the area, 1.4 million, over the area of the model. And now we are simply going to cross multiply and solve. And we divide by 2,500 on both sides. And we get that the area of the model, 560 square yards. Make sure when doing these problems you are checking your units. A lot of times the units in the problem will be different, and thus when doing the answers you will be needing to convert at some point.